Hello, good evening.
Hey, Mr. Hoya.
How's everything? How was your vacation? Oh, your vacation? No, your long weekend. Oh my God, that's a full vacation. Did you
Good
guys
afternoon. Good
enjoy?
afternoon.
Good
Yes, we
afternoon.
did.
How you
Yes.
doing?
Good. Thank you.
Yeah, it was a little longer than expected, but well, it was good, right? One extra day off, not bad.
Of course. Of course it is.
Yeah, particularly after, Saturday, Sunday. Mondays usually are a little kind of lazy. Not only for you guys, it's lazy for me. Okay, so I hope you all enjoyed that long weekend. So now we're gonna continue with this chapter. We are gonna be done with this module pretty soon. So just hang in there. A little few days and that's it. We're gonna start another module. Okay, so once again, if you guys have any questions, feel free. You can ask me the questions anytime you want to. If you're gonna send me an email, that's fine. If you wanna ask me during the class, if it is something related to the class, if it is something personal, don't speak during the class. Just drop me an email and I will be more than glad to assist you. Okay, so let's start with the digestive system now. So as all of us are familiar with this system, but we don't know certain structures, we don't know certain conditions, and of course, how the digestive system works together alongside with all these structures that it makes the digestive system. So we know that we eat something, it goes through the mouth, then it goes somewhere, and we know that ends up in the stomach. And from there, something happens. You don't know what happens. We're going to find out. Then whatever is not used, whatever is a waste, is going to come out through the large intestine to the rectum, to the anal canal, outside that we call it feces. So that's basically what it is. But we're going to talk about what happened during all this process of food being ingested, which structures it passes through, what happened during this process of passing the food through all these alimentary tract, and what happens in the stomach, what happens with the small intestine, what's going on with the large intestine, what structures makes up the digestive system, the upper part of the digestive system and the lower part of the digestive system. What happens when some of these structures do not work properly? What conditions you're going to develop? We're going to talk about some of the conditions of the digestive system. So digestive is not just eating and digesting and then getting the wastes out. That's not just digestion. Lots of other things happens at the meantime. So we're gonna go over those. So let's see. There are two types of digestion. So think about this because it's very important that we understand how that happens. So one of the digestion is called mechanical digestion, and the other one is called chemical digestion. Now, what is the difference between those two? What is mechanical and what is chemical digestion? Well, if you see here, it says mechanical digestion. So mechanical is something that is done voluntarily, if you will, because we are going to use the mouth, the teeth, and we're going to chew that whatever solids we ingest or we put inside our mouth. So these particles are large particles, like bread, like fruits, not juices, not talking about liquids, because those also passes through air, but it doesn't need to break down. It's particles that needs to be broken down. Pieces of steak, eggs, fruits, I said again. So there are a lot of stuff that we eat, the rice, the bread. So whenever we put them inside our mouth, some of the particles are very large. So they are going to be very difficult to swallow. For that reason, we have to chew those particles. Chewing means breaking down. We're going to break them down in small pieces. Now they can be swallowed. Now they can go down through all these pipes that we're going to give them names as we move along with all the structures of the digestive system, starting with the upper part of the structures of the digestive system and the lower part, just as we did with the respiratory system, because it's very similar. So that's basically what it is. So that is called mechanical digestion. Chemical digestion, on the other hand, it happens within the stomach, because within the stomach is going to release some chemicals, and these chemicals are going to break down even further those pieces of food that we chew in the mouth. Now they pass to the stomach, but the stomach is going to use a different approach, a different process. Now, certain chemicals that we're going to discuss them later on are going to break down this food that we have already chewed and make it smaller. So small that can be absorbed through some structures of the digestive system, and then it goes to the bloodstream. So that's how these nutrients are going to be extracted due to this chemical digestion. Now they're going to pass through some walls of some structures, and then they're going to go to the blood system. That's how sugar, cholesterol, vitamins, minerals, water, proteins, vitamins, all of them are going to pass through the bloodstream. So remember, we talk about the blood being the media of transport for all the nutrients, all the hormones, all these chemicals. But the same way that it transports them also has to remove wastes. Well, the digestive system is not an exception. It does almost similar, using different structures, of course. And whatever is good for the system, whatever it needs to be absorbed to the bloodstream, is going to pass through these structures. Whatever is not needed is going to go down to the large intestine and then discard as a fecal matter. So that is the chemical part. So it's not difficult to understand now, because when we eat, that's what we do. We chew this food. We masticate, if you will. That's another term that we use. That is the chemical. I'm sorry, that's the mechanical digestion. So that's basically what it is. So we are going to talk about these structures that makes up the digestive system. All these organs that carries out the mechanical, the chemical, the absorption and the excretion. Because remember, we talk about digestion meaning the mechanical part, the chemical part, the absorption, meaning how all these extracted nutrients from food that we chew then goes through the bloodstream. And the excretion, which means how the wastes are removed. So it's an excretion or defecation. These are the correct names. We don't say, we don't name these giving these, how am I gonna say, use slang to pronounce this, to mention how these fecal, material or matter comes out, giving it different names. We have to be a little professional and explain the patient, even though if they don't understand much these terms, you have to use appropriate terms without being, you know, uh, very expressive with information to our patients. So that's basically what it is. So we are going to start talking about all these structures because the major functions of the digestive system is digestion, absorption, and excretion. And we're going to see that exactly which one of these parts takes place with more details, because I just went over a little overview, just touching bases on what does the digestive system um, do. So that's basically what it is. So let's talk about first these organs that makes up the digestive system. So the digestive system consists of two portions, two segments, two areas, whatever you want to call. So we have the alimentary canal, which are all those structures that we're going to mention. These are the main organs. And we have some accessory organs. Every single system have accessory organs. And remember, they are not the main ones. They are not even part of this digestive system. They provide something that they produce to the digestive system, but it's not part of the structures that we are going to be describing. So the mouth is the first structure of the alimentary canal. Remember, this is the place when we put the food, then we start chewing it to make it smaller, to make it easy to be swallowed. Then we're going to have another structure that is called the pharynx. Remember, this is the throat. So from the mouth, the food is going to move to the throat. Then there is a tube that is going to bring the food from the pharynx to the stomach. That is called the esophagus, which is this part right here. This is the esophagus, this tube. Here is, we have the pharynx, and this is the mouth. Then the food is going to end up within the stomach. After we chew it, it's going to come right up, my bad. The stomach is right here. So this tube right here, the esophagus, is going to be attached to the superior part of the stomach. Then these are just tubes, pipes, passageway of food and liquids. When they reach the stomach, and after digestion, they're going to pass to the small intestine. So which is all these kind of pink structure right here. That is small intestine. Then from the small intestine, it's going to pass to the large intestine. Then to the last part of the large intestine, which is the rectum. And then the anal canal, which is the last structure, like this ring-alike structure. And that is it. That will be all the structures of the alimentary canal that are called the main organs. So now let's mention, we're going to talk about each one of them, of course. We're going to describe the mouth, what is within the mouth. What else? The mouth is not there. It's not just an opening. It has other structures. And how these structures are going to assist during the process of mechanical digestion. What is it that they do? Then we're going to have the accessory organs, the teeth and the tongue. So think about this. We might be thinking, well, wait a minute. The teeth and the tongue, they should be main organs. But remember, every single time that we talk about main organs, it means that without these structures, there is no digestion. There is no chewing. There is no way that we can pass some food. Yes, we need the teeth, we need the tongue, but without them, can we manage to get all the nutrients? Yes, you can. So the teeth, the tongue, the salivary glands, remember those glands that produce saliva? All these structures are within the cranial cavity, within the mouth, within the facial spaces, cavities. But they are secondary. They are not the main organs of the digestive system. So that's basically what it is. Later on, we will discuss why isn't a main part, the teeth, the tongue, and probably the salivary glands that are located within the facial cavities. Then we have the liver, which is outside of this because it's right here. Has nothing to do directly with the digestive system, but it does produce something that we're going to talk about later on that assists with digestion. Then we have the gallbladder, another structure that does not belong to the digestive system. That's what it's called accessory. Last but not least, we're going to have the pancreas. The pancreas is not one of the structures of the organs that makes up the digestive system. But it produces something that is going to help the chemical digestion of food. We will be talking about each one of these structures individually. And of course, we're going to talk about what is the functions, what is the role of each one of these structures within the digestive system. And then we're going to figure it out why isn't that some of them are not main organs of the digestive system. Why are they considered only accessory organs, like assistants? We'll find that out. Any questions about these two types of portions or segments of the digestive system. Remember, we're going to have some main organs and we're going to have some accessory organs, just as we did with the reproductive system. We have essential organs, or main organs, and some accessory organs. So that's how it works. So let's talk about a little bit of this tract that helps to pass the food through, helps with digestion, and helps with absorption, and then with the excretion of all the wastes that are not used within the alimentary canal. Just like any other organ, remember, these structures are made of walls or layers. So the alimentary canal has 4 layers, 4, not 3, as the other organs that we have discussed. The outer, the middle, and the inner. Here we have a little more than that. These are very, very special organs. So let's define them. So here we have the mucosa. So the mucosa is the inner part of these tubes, these pipes that allows food to pass through. So if you look right here, let me remove all this from previous class. I have all these drawings. Okay. So here we have the mucosa. So it's that innermost layer. So we start from the inner part, right here. This part inside is called the mucosa because it is a moist, slippery structure, membrane. Because remember, it has to be moist and kind of slippery because it's going to allow the food to pass, to slide through. Otherwise, it's going to be somewhere stuck. No, we want something that passes through these tubes easily with no troubles. So that will be the mucosa. Now we have the submucosa. Now this is a very tiny layer that is between the mucosa and the muscularis, which is the muscle. It's a very tiny membrane. Do we need to know this for the exam? No. But you need to know all the structures, or at least some of the major structures of the digestive system, and understand how the food and any of its stages passes through these tubes, and what happens when something gets stuck right there. What happens when this mucous membrane get damaged? What is it that we're going to develop? What conditions are we exposed to it or at risk to develop? Because we have lots of conditions that happens to the digestive system. Remember, the digestive system passes lots of things that can be detrimental for the digestive system. Lots of foods that can damage these membranes, or wastes that can damage the membrane. We will go over this when we start talking about all these chemicals that are secreted to break down this food that enters the stomach and then moves to the small intestine. Because remember, these chemicals, if they break food, what make you think that they're not going to break this mucous membrane and cause you damage to it and cause your condition? So here we have the muscularis. As the word implies, this is the muscle of this alimentary canal. So that's basically what it is. This is the muscle. This is the thickest part of this digestive tract, if you will. We can call it alimentary tract, digestive tract. That's not a problem because anything is something that allows the food to come from the mouth all the way to the stomach and then to the small intestine, to the large intestine, and wastes out, and everything else will be absorbed. Serosa, this is the outer layer, which is this one right here. This is the muscularis. All these red part is the muscularis. So this pinkish one, this is just a very tiny membrane. This is the submucosa. So that's basically what it is. So just remember that every single structure of the digestive system or whatever other system, whatever other organ that we're talking about, it's going to have walls or layers, particularly when they are hollow inside, when something is passing through these pipes, so to speak. So this will be the alimentary canal layers. So again, it's not something that you will be asked on exam, but we need to describe this due to the fact that we are going to have certain conditions that are going to affect this inner layer of the digestive system or inner layer of the digestive tract or canal. Let's talk about these movements that happens to make the food to move from the mouth all the way down to the stomach, and all those wastes leaving the stomach, moving through the small intestine to the large intestine, all the way out. So we have two types of movement of food through this alimentary canal. One is called the mixing movement. So think about this. Simple. Mixing. Mixing means like, from right to left, up and down. So it's shaking. Stomach shakes food inside from side to side, from inferior to superior, from top to bottom. So it's shaking the food like this, and like this. That is mixing. It was similar like a blender, if you will. So sometimes when we eat something and it's a lot and it's most of them solids, we actually want to hear our stomach like rumbling inside. That's because it's doing this movement, mixing the food inside with all these chemicals to make sure that every large piece is broken down into very small pieces. So that's basically what it is. Then we have the propelling movement. The propelling movement, usually we call it peristalsis. Now, peristalsis is a common question for exam because peristalsis is nothing else than this waving movement that the foot, that the intestines or the alimentary canal does as the food is passing through. That's how the food is being allowed to pass through these flexible canals, the digestive tract. So if you look right here, remember peristalsis is a wave-like movement. It's like waves, goes like this. So let's talk about this mixing. You see here how the food fits in right here within the digestive system, within the stomach, because the mixing happens within the stomach. Okay, that's the place. So here it mixes. So here the food is there. Now start sending the food side to side, up and down. So that's the mixing part. Now the peristalsis or the propelling movement is right here. See, right here is showing how it works. But let's move to this second image right here. See, as food passes through this canal, you know what it makes the food moves to the next level, is this peristalsis movement, this wavy movement. So this tracks kind of narrows and pushes the food down, and when it passes, narrows and pushes again, narrows and pushes again. So that is basically what it happens right here. So let's say that this is the tubes or the alimentary tract. Food passes here. Now, here, this part narrows so it can push the food down right here. When the food reaches this point, then food moves here. This piece narrows again and pushes again. So this narrowing pushes the next part. Now it narrow right here, it pushes again. So it goes like this, like squeezing, passing, passing, and passing. That's how it works. As it is portrayed, depicted right here. See, food is here. Now to move to the other end, it stretches right here and pushes this. When it pushes this right here, now it's gonna move to the next level and squeezes right here, stretches right here and pushes until all the food has passed to the stomach. And the same happens with the small and large intestine. From the large intestine, whatever was not used is gonna be sent all the way through the large intestine to the rectum, to the exit, which is the anal canal, in one direction, of course. Sorry, guys, again, something happened to my PowerPoint presentation. Oh, to my computer, I'm sorry. Okay. So let's see. Let me get all this right. Hmm. With this kindly. Okay. So sorry again. This computer is killing me because the battery goes off really fast and I forget to charge it again. So, and it doesn't give me the notification. It used to kind of screen pops out and tell me that, the battery was about to collapse, but this time it didn't give me no signals, nothing, as usual. Okay, so we are talking about this mixing movement and this propelling movement. Remember, the one that you need to know is peristalsis. They're gonna ask you, what is peristalsis? Oh, this is the wave-like movement that helps to push food, something down. And that happens mostly within the digestive system. So that's basically what it is. So peristalsis, peristalsis, peristalsis. Don't forget about that. That's very important. Okay, next. We're going to start with the structures or the main structures of the digestive system. And of course, we're going to talk about these accessory organs that are within these structures. Particularly in this case, we are going to have the teeth, the tongue, and the salivary glands. And we're going to talk about them. So let's talk about the mouth. So as very basic statement, the mouth is the first part of the alimentary canal or the digestive system for that matter. And what happened right here? Mechanical digestion happened here. How's that? Well, we are going to break all these solids that are large particles and we're going to make small ones so it can be swallowed. They can pass through the pharynx, through the esophagus, and reaches the stomach. So that's basically what it is. So what is the process by which chemical digestion happens or occurs? Mastication or chewing. See? Is the mechanical breakdown. Now, this mechanical breakdown, yes, helps these large pieces of meat, chicken, bread, whatever we eat, to break it down in small particles. But these small particles by themselves, if they are dry, they're going to be difficult to pass all the way down. So for that reason, we have the system of the salivary glands. Because the salivary glands, what they're going to do is they're going to provide us with some moist. So whatever it is that is dry within the saliva is going to mix it. Then we're going to make like a bowl, if you will, that's called bolus. And that ball is going to be able to move down the pharynx, the esophagus, through this propelling movement or peristalsis. So the salivary glands are very important because they provide this moist to the food that we eat. So after we chew it and chew it and chew it, we make like a ball. Think like a meatball. Then with the assistance of the tongue pushes that down and it goes all the way through the pharynx, through the esophagus, to the stomach. So the mouth is very important because that's how the process of mechanical digestion begins. The mouth. Any questions about the mouth or any other parts of the chapter that we have already covered? So let's talk about now the tongue. Because we saw right here, right? This is the mouth, has all these structures. Now the tongue, then we're going to talk about the teeth and the salivary glands and see which are their functions of these structures. So we're going to talk about the tongue. This is a muscle. It is an organ. And what is the major function of the tongue? Remember, during the process of digestion is to push the food down the alimentary tract, just as I mentioned it before. So when we masticate, when we chew the food, the solids, the tongue is going to push it down. But before it has been mixed with saliva, makes like this ball, like meatball, and send it down. So now it's going to be easy to kind of travel through the tracks with the assistance of the peristaltic movement. Remember that we talk about within the senses that the tongue also is this organ that contains the taste buds. So all these areas when we can taste sweet, salt, sour, bitter, and umami, which are all these other flavors like proteins. So in this case, for the digestive system, all of that is important. It's not just for the taste buds. Remember, the tongue is a muscle and it's very flexible muscle that we can push it back, and that helps to send this mass or this ball of food all the way down. So that is the function of the tongue. That is it. Just in case, remember, if somebody asks you where the taste buds are located, so you know they are on top of the tongue, not on the lower level. They are on top. Now we're going to have the palate. We didn't mention it, but this is part of the mouth. This is the roof of the mouth. If you take your tongue and the tip of the tongue, you pull it up and touch this area on the roof of your mouth, that is called the palate. But we have two types of palate, the hard palate and the soft one. So we have the hard one because it's bone, and the soft because it's mucous membrane. So this area that I'm gonna highlight right here, this is the hard palate. All this part, if you kind of raise your tongue to touch the roof of your mouth, You feel like it is hard right there. It's like bony. So that is called the hard palate. This one right here that goes inside, that connects with the pharynx, this part of the roof of the mouth inside is called the soft palate. That is when we have the tonsils all the way down. See, you see this tunnel right here, all the way down the roof of that part, because this is separated like two ceilings. This is one, and right here on the back, going through this small space, that's what the food passes through, right here. So right here on the back, there's another ceiling internally on the back of the mouth that is very soft. That is like the mucous membrane of our cheeks. Very soft tissue. So that's basically how this works. Now you see this little bell-like structure right here. It looks like a little bell hanging right there in between the hard palate and the soft palate. It's called the uvula. What is the purpose of the uvula? What is the uvula doing there? Is it this just a decoration right there? No, it's not. The uvula prevents things from going through the nasal canal. See, back here on the subcanal, there's an opening. This is like another roof over there, another room where the food is going to go into. So when the food, we chew the food, this uvula doesn't allow this food to go to the nose, to the nostrils, to the nose. Probably have happened to you that when you are eating and sometimes you talk, what happens when you eat and talk? Then you choke yourself because the food tries to go to the wrong side, through the larynx instead of going through the pharynx or through the esophagus. So remember the epiglottis, that little lid that closes the larynx when you breathe, when you sing, when you talk, and when you eat, that door closes and it closes the larynx. But if you're eating and talking at the same time, food tries to go through that area because this lid is opening like fanning. So food can go through there. But because food cannot go through there, we have a mechanism of causing you to cough. So when you cough, because that's what happens when you choke, something goes on the wrong way, and you cough, things can come through your nostrils. And don't tell me that this have not happened to you, because this happens a lot. That we eating and we're talking and we're laughing, or somebody did something, and then we laugh or we talk, and then boom, we choke, and all these particles, solid particles, comes not only through our mouth, but through our nose as well. So that uvula prevents that from happening when we eat it. You're not supposed to be talking. You're not supposed to be singing when you eat it. So that's basically what it is. So that's the function of the uvula. So it has a function. Remember, the tongue pushes food all the way down. The uvula, that little bell-like structure, and the center of the hard palate that separates the inner part, which is the soft, is there to prevent, once again, the food goes through the wrong channels, which is the nasal canal. So it does have a function. So that will be the soft and the hard palate and the uvula. So that's basically how this works. So let's move on. Let's talk about the teeth. Let's going to talk about these teeth from the newborns and the teeth from older people. So these structures, the teeth, are made of these very hard structures, these bony structures. They are very hard. They are the last to disintegrate, to break down after death. See, the cranium that can last for years, exposed somewhere. But the teeth stays even longer. So that can be a proof of forensics, if just in case they find a body and then can identify through DNA from any piece, but usually soft tissue breaks down easily, but bony part stays for a long time, years. So we have two sets of teeth. We have these primary teeth and we have secondary teeth or permanent teeth. So that's basically what it is. Usually they don't ask you how many primary teeth there are. Remember, primary teeth are those teeth that the babies are born with, or those, well, we are born with the teeth. It's just that we don't see it. They are within the gums, the gingiva. But after 9 months, a year, those teeth start coming out. But these are the teeth that we kind of drop after certain time. They fall off. That's what they call primary. So there are 20 primary teeth. This primary teeth has different names. So sometimes these are questions for exam. What are the name of the baby's teeth? Well, they are called deciduous teeth. That's one of the names. They can call milk teeth. They can call the baby teeth, the temporary teeth. See? See all the names that we can use for those primary, first 20 primary teeth from the child? Remember, these are the ones that are changed, that we are dropping, that they are fall off, and then the permanent ones come out. There are 32 secondary teeth. This is only known as permanent because they stay, that's it. If this teeth falls off, they're not gonna be regenerating again. That's it. We have to do other methods of getting that teeth back with a prosthetic teeth. So that's basically what it is. So these teeth are divided in a group of teeth, the primary, the secondary, but they have other names, the incisors, the premolars, the molars, the canines. We're not going to talk about them. These are not things that you will be asked. But remember, these deciduous teeth are the baby teeth, the temperate teeth, the milk teeth are the same. These are the first primary teeth that comes out. Anything else is going to be permanent. And if you see the little babies, they don't have the entire upper or lower maxilla filled with teeth. They have some. As an adult or after certain years, then you're going to have the entire group of secondary teeth. So remember, the last teeth to come out are the wisdom teeth. So this will be the molars, these ones right here on this side. So that's about it with the teeth. Any questions about primary or secondary set of human teeth? Okay, let's talk about one of these structures. We select a single tooth, and we're going to talk about its parts, its layers, because it is important. So just for you to know, who knows, might be asking you something. I will tell you if they ask you about something about the tooth, more likely what will be. So let's talk about, I'll leave it in blue, the parts of a tooth. So the upper part, the part that is visible, is going to call the crown. The crown. This is the visible part of the tooth, the part that we brush. Then we have the root, which is the part that it is within the bone. Because only we can see part of it. But there is another part, the root, just like a tree. We see the trunk, which is the branches, the leaves. But under the soil, we're going to find the root. So the same with the teeth. The root is right here, separated by the gingiva or gums. So this is the part that we see. This is the part that is within the bone. So the crown and the root, those are the parts of a tooth. Now, if we are going to talk about the layers of a tooth, then I'm going to mention them. It has three parts. So remember, it has two parts and it has three layers. Now we go back to the three layers. Remember, the digestive system has two layers, four layers. But this tooth is going to have three layers, as many others do. So we have the enamel. What is enamel? All these white part. See? The white part of the eye, the visible part of the eye, the tooth, I'm sorry, is called enamel. So if they're gonna ask you a question, that's how they are going to ask you. The white part of the tooth, what is called? I was mixing it up with the white part of the eye. Remember that this is sclera, but we're talking about the tooth. So it's called enamel. Remember, the white part of the eye. That's the first layer. The middle layer is called dentin. Dentin, which is all this yellow part. All this yellow part is the dentin. That is the thickest, the hardest part of the bone, the dentin. Then we have this center. See this center part of the bone? Right here, the center. This is called the pulp. Now, why is it that the pulp is so important? Because here we have blood vessels, we have the nerves. So when we get perforated this tooth and it reaches this deep right here to the pulp, we are going to feel this terrible toothache. Why? Because it's exposing the nerves right here. That's what they do the root canal. And during the root canal, what the dentists do is to neutralize these nerves. In other words, they're going to kill the nerves. So you don't feel the pain anymore. These are the structures of a tooth. Remember, it has two parts. The visible part of the tooth, or the upper part of the tooth, the part that we brush and all the stuff, is called the crown. And the inner part, you don't see it. It's called the root. Then it has three layers: enamel, dentin, and the pulp. Remember, this is a cavity right here where, see, blood vessels, nerves. So the yellow one is the nerve. The blue one is the veins. The red one is the arteries. Remember, these structures are living structures, just like bones. They are living structures. And they have nerves, blood vessels, and that's what they hear when something happens to them, when trauma to them occurs. So that's basically what you need to know, the basics. Remember, if they ask you the visible part or the white part of the eye, the tooth, I don't know what I'm doing with the eye still, it's called enamel. Where do you find the nerves, the blood vessels within a tooth, within the pulp cavity? What is the hardest part of a tooth? Dentin, the middle layer. Any questions about the tooth? Okay, moving on. Let's talk about the salivary glands. So remember the tongue, the teeth, the salivary glands are considered accessory organs. They are not the main organs, structures of the digestive system. So the salivary glands, as the word implies, the salivary glands produces saliva. Easy, right? Now, what is the function of saliva? Remember, it moistens food particles, so it binds them together. Remember, they make this ball, and actually it's called bolus. We start chewing and moving the food all the time right there with our teeth, breaking it down, chewing it, masticating it. Then saliva is mixed alongside. So it moistens and it makes this ball that can be easily swallowed. That's basically what it is. See, it says right here, dissolves and lubricates food so it can be swallowed. Can you imagine a piece of bread without saliva? A toast put in your mouth, a piece of meat all dry, try to swallow. You're not going to be able to. You start coughing. This is a gut reflex. Have you tried to put something inside your mouth, like your finger sometimes? You gag. The gag reflex immediately make you cough, make you want it to vomit. So every single time that we're going to eat, can you imagine that you feel that sensation? You're going to be able to eat. You'll be bulimic. Because that's what bulimics do. They eat and then they put a finger inside their pharynx or the throat so you can develop the gag reflex so you can vomit whatever you have eaten. So this saliva contains enzymes. Which enzyme contains saliva? Amylase. Amylase. And what is amylase good for? To break carbohydrates. Carbohydrates are sugars. So we start the process of digestion within the mouth because this is the process of digestion. Not only breaking the food down in pieces, but now we are adding these chemicals. So we can start breaking carbohydrates, those sugars, those starches. Remember these vegetables like potatoes, bananas, sweet plantains or green plantain, everything that we eat contains starch. Corn contains starch. That's a sweet. That whatever makes these, the rice contains starch. That's what it contains carbohydrates. And if you eat too much rice, you gain weight. So right there within the mouth, with the help, the assistance of saliva that contains this enzyme called amylase, you're going to be able to break down carbohydrates. There are three types of salivary glands. We have the parotid glands that are located right here to the sides of the ears. We're going to discuss this a little later, but I'm giving you a little heads up on this. The submandibular glands, because they are located underneath the mandibles, and the sublingual glands, which are located underneath the tongue. All of them produces saliva. Some of them is very liquid. Some of them are like jelly-like. And that's what makes these food to stick together like a ball. Now that small ball of food can go down the alimentary tract to the stomach. And it's called bolus. We're going to talk about that. Remember, it's a ball, it's a bolus. So that is the importance about the salivary glands. So we're going to talk about this because the largest of these salivary glands is the parotid glands. Any questions about saliva or the salivary glands or the enzyme that produces the salivary glands? Remember, amylase. And what is this enzyme good for? It breaks carbohydrates. That's it. There are three pairs of salivary glands. The parotid glands, located once again on the sides by the ears. The submandibular, these are under the mandible, and the sublingual, which are under the tongue. So here we have them. So we're going to look at these glands. So here are the parotid glands. See how huge they are? They are right here by the side of the face, one on this side by close to the ear and the other one on the other side. So that is how this works. It's the largest of these salivary glands. See? Anterior, inferior to the ear. Anterior means in front. Inferior is like going not on top of the ear, but to the lower part of the ear. You probably heard about mumps. Remember, these are this viral infection that occurs to the salivary glands, particularly in males, the little kids, and they see that they have this bulging right here close to the ears. That's an infection. That's a viral infection that causes that. That's why the little babies are being vaccinated with mumps, measles, and rubella, MMRs. This is the gland that swallows with the viral infection. It's called mumps. So these are very large. But the major function is to produce saliva. Now we have the submaxillary ones. Submandibular, I don't know where I'm going so much. Submandibular is below the mandible, right here by the sides. Probably when you go to the doctor and you're complaining about coughing and having sore throat, scratchy throat, or you have pain on your throat, or you have problems swallowing, the doctor's palpates right here underneath the mandible. Remember, this only structure from the face, the only bony part that moves is called the mandible or the lower maxilla. So whenever we have inflammation of these glands, probably we have some viral infections. And the doctor kind of palpate this area. We can feel it right here in this soft part on the sides underneath the mandible. Right there are the salivary glands, the submandibular. And then we have the sublingual, which is right there underneath the tongue on each side. Remember that here we have something that is called frenulum. It's a little membrane that holds the tongue. It's kind of dividing the tongue on the floor, on the bottom, on the base of the tongue, and we have a little kind of membrane right there that is called the frenulum. So we have one on this side, the other one on the other side, because we have pairs, one on the right side, one submandibular, other on the other side. So these are three pairs, remember. The largest one is called the parotid glands. So if they're gonna ask you something about this, probably is the sublingual glands. Why? Because they are underneath the tongue, because these glands are the ones that produces this saliva that when we put this little pill underneath, tablet, underneath the tongue, that's called nitroglycerin, it dissolves this pill because this pill needs to be, or this tablet needs to be administered that way, sublingually. We cannot chew it, we cannot swallow it, and it has to just dissolve right there within underneath the tongue due to the saliva. So that's something that you should keep in mind. Remember, you will be asked on your national certification, what is the name of the tablet or the medication that is put under the tongue? Nitroglycerin. Nitroglycerin is a medication, is an anti-arrhythmic medication, and it helps to dilate the blood vessels in people that has coronary, arterial coronary disease, or CAD, people who has heart problems. So they develop chest pain. When they develop chest pain, it's because not enough blood is reaching the myocardium of the heart. So therefore, this medication makes the blood vessel to open up, to widen, so more blood passes through. And that releases the pain. So for that reason, that medication is taken, but it has to be taken sublingually. We put it right there underneath the tongue, it dissolves right there. Should not be chewed, should not be swallowed, nothing, just dissolve right there underneath your tongue until it dissolves. It's very small, very tiny pill or tablet. Well, any questions about the salivary glands? Remember, three pairs. The largest one's called parotid glands. The ones underneath the tongue, easy. Sublingual. The ones under the mandible, submandibular. Sub means under. Let's move on. The pharynx. Remember that the pharynx is also known as the throat. So this is a common space for food, liquids, and air. Remember this part right here is common for all these functions. That's why it has a channel that connects with the nose, nasopharynx. See, it connects with the nose. Oropharynx, it connects with the mouth. Laryngopharynx, because it connects with the larynx. So this is the larynx right here. So it is a common place, once again, for all these structures. Right here. So this is like the train station. Then from here, remember there is a lead, the epiglottis, that is going to cover the farting, the larynx, when we are talking, when we are breathing, when we are singing, whatever it is. And when we eating, it's closed. When we are eating, then close, and when we're talking, things opens, and it closes the other end. That's what it's called like this, because it connects different structures: the nose, the mouth, and the larynx. That's what it's called: nasal, pharynx, oral, pharynx. Remember, oral means mouth, comes from oral, nasal comes from nose, laryngo comes from larynx or the voice box. So that's basically what the pharynx is all about. Remember, it's very important to know that the pharynx is a common place for food, liquids, and air. Everything comes to this place and then is distributed accordingly. If it is air, goes to the larynx. If it is food or liquids, it goes to the esophagus, which is right there on the back of the trachea, which is the structure that connects with the larynx because it's the part of the respiratory system. Any questions about the pharynx? What is another name for pharynx? Remember, throat. Those are the things that you should always be keeping in mind. The pharynx, it is the throat. The larynx, the voice box. The trachea, the windpipe. So know the second name that is the most common use. Okay. Move on. Let's see what is the next structure right here. The esophagus. Remember, we are walking from the mouth, the pharynx, the esophagus, now then the stomach, then the small intestine, the large intestine, the rectum, the anal canal. We are going to be talking about every single structure and what happened within one of these structures, what processes are occurring there. So that's basically what is important, because remember, we're talking about anatomy, structures, physiology, function. What is the function of these structures? Now, the esophagus is a passageway. It's a muscular food passageway. Well, not only food, liquids, whatever else the person swallows goes there. So it connects the pharynx to the stomach. So that's basically what it is. So common questions for exam. What is the name of the structure that connects the pharynx or the throat to the stomach called esophagus. Esophagus. Now the esophagus have two valves, so to speak, that we call it sphincters. So we have one sphincter right here where it connects with the stomach. It has a sphincter, like a valve. Remember the heart has a little valves that allows to pass the blood through, or when it closes, doesn't allow the blood to go backwards. Well, exactly like this happens, but this is called a sphincter. It's muscle ring. So we have the lower esophageal sphincter, or LES. This is called LES, lower esophageal sphincter, which is the part of the sphincter that connects, that is located where the esophagus connects with the stomach. And we have one that is called on the upper part, which is around here when it connects the pharynx with the esophagus, that is called the cardiac sphincter. Cardiac sphincter. See, it regulates food passage into the stomach. So the lower and the upper. So this is like a faucet. Remember, we open it to let water run out, and we close it to prevent water from running out. So that's basically what it is. Now, these valves are not like the valves of the heart. No, these are rings. So these are the tubes, and it has one ring right here, a muscle, and another right here. So when the brain stimulates these rings to open, they relax. This is the nervous system. They relax, food passes through. When it passes to the stomach, now the food reach the stomach right here, the bolus, enter the stomach. Now this closes. Why? Because we don't want the food to go backwards, because that's going to cause esophageal gas reflex, or just some type of acid reflex. So that's what we have, these structures right here. Very, very important. The same with this. Sometimes you feel like you have a knot right here on the throat, like food don't want to pass. It's because this sphincter is closed down and it doesn't allow much food to pass. So the brain is telling you it's closed, and you're forcing it to put more food through it. So that's basically what it is. This one, lower esophageal sphincter, prevents food from coming backwards to the esophagus, because remember, it causes acid reflex. Not gastritis. Gastritis is within the stomach, not within the esophagus. When you feel this burning sensation right here on your throat, it's because content from the stomach went backwards. That's called regurgitation. So that's basically what it is. This is important because you are going to understand when the patient comes into your office and says, oh, I have some acid reflex. I feel like something bitter right here in my throat. It burns around here. Remember, that is called heartburn as well. Acid reflex. But most of the time, we call it heartburn. That's it, because it burns this area right here. Because the content, all these chemicals right here from the stomach, outside the food that enter, goes backwards because this sphincter did not close. And then we feel this sensation right here within our throat. That's the esophageal acid reflux. Heartburn, once again, is the common name, the layman term that we use for that. So this will be the esophagus. So usually the cardiac sphincter, they don't ask you, but they can ask you, okay, where is the LES located, or lower esophageal sphincter? Oh, it is located. Remember, as long as you understand the acronym, or if they spell it out, it says esophageal. Oh, esophagus, pertaining to the esophagus. But it's the lower. Oh, the lower part is right here. Is the part that connects the esophagus with the stomach. That's the sphincter. So remember, when we eat, it's because we were hungry most of the time, so the body wants food. So we eat. So the brain sends signals, make us hungry. Then we start eating, opens all these sphincters, so food can pass through easily without any problems. That's why that after eating, you shouldn't be jumping, you shouldn't be doing anything, no exercise, no activities. Because the process of mixing is occurring right now, and it lasts 2 hours. So from the moment that you ate and your stomach is full, or even though it's still not full, you're not putting anything else, the stomach start working, start mixing, start shaking this food inside. And now on top of that, you're running, you're moving, you're doing something, or you're laying down. Immediately, this valve is going to open up and food is going to seep out. That's why you shouldn't be eating and going to sleep or laying down on the couch immediately. You develop acid reflux, heartburn. Shouldn't be going running to the gym. No, get some rest first. You shouldn't going to sleep after you eat. That's why in the evening you shouldn't be having a large meal. Number one, because in the evening when we eat too much and we go to sleep, then the digestive system becomes very slow. So you're going to absorb every single nutrient. And remember, nutrients, we have fats and glucose, and those are the ones that comes in large quantities in our food. So that's going to make us gain weight. So the evening is not an appropriate time to eat. Not a large meal, not a heavy meal, something soft, like cereal, like fruits, juices, some crackers. Because now is the time for you to go chill, go lay down on the couch or the bed. So usually I'm going to my bed, but not right immediately after eating, because I like to watch TV from my bed, not from the living room, because now my son is not here. So when I share with him, then I sit in the living room, we watch something, or we play something. But by myself, oh no, I'm going to my bedroom. But I don't eat and go and lay down. If I eat something, then I start doing something on my computer. But I usually don't eat heavy meals at night because I know that's going to cause me problems. And I don't want those. I don't have no acid reflux. I don't have no gastritis. I don't want them. So then I do the right thing. Why? Because I know how it happens. And that's what I want you to learn from here. So when a patient comes in, the doctor is going to explain then all the things that I'm telling you. And if the patient continues with the same habits, bad habits, they're going to continue taking the medication. They're going to continue coming to the doctor for the same issues. Then you know what causes it. So you can apply it to yourself as well. So this is the esophagus. So once again, questions that are important for exams is, what is the name of the structure that connects the throat pharynx to the stomach? How it's called? Esophagus. Where is the lower esophageal sphincter located? It connects the esophagus to, it is located between the esophagus and the stomach. That's it. That's what you need to understand. Because these are very basic questions. But then everything else, because we're going to talk about heartburn of esophageal reflex, we're going to mention it again and again and again. So it's kind of, sticks more in your brains than if I just mention once. This is a very, very common, it's the most common condition of the digestive system, acid reflux, heartburn. It's the most common. What is the most common condition of blood? Anemia. Anemia. See, we always have something that is very common in something when you develop something. Moving on. The next structure, of course, we mentioned it already, is the stomach, because the esophagus connects the pharynx or throat to the stomach. So now we're going to talk about the stomach. Well, it says there that the stomach is a J, like a letter J shape, pouch-like organ. Nobody's going to ask you that. Nobody's going to ask you how long, how wide it is. No. What they're going to ask you is
Professor,
what
can I ask you a
exactly
question?
the stomach does. You asking me a question?
Yeah, I wanted to ask, what did you say about acid reflux? Most common condition of what?
Of the digestive system.
Thank you.
You're welcome. And that's why I'm telling you about it. So when you see this question on your exam, you immediately remember that I mentioned it. Because it's not just saying, okay, this is the most common and that's it. No, you have to tell how it happens, how the heartburn, how the esophageal reflux happens. Because if I don't tell you, you're not gonna know what is the sphincter's function and what exactly happens. How do I develop this burning sensation right here? This bitter sometimes secretions coming out my mouth, tastes so bad. What is it? Because it's all the content from the stomach that is already being chemically mixed. Because remember, this is where chemical digestion happens. Now the door is open from the stomach and this food ships out. That's what it burns because these acids from the stomach are, these secretions from the stomach are more acid than the lining of the esophagus. So the pH is completely different and it burns that. It's like you putting a cigarette butt right here in your skin. I said, oh, I'm going to turn it off right here. I'm going to just smack it on my skin. That's exactly how happens when these acids goes back on the esophagus. It burns the mucous membrane. Remember that I told you that the mucous membrane is very important because the mucous membrane is the same that is going to happen when it burns, it damages due to acidity within the stomach. Now you're going to have like a burn right there in your mucous membrane within the stomach. That will be gastritis. See, little by little, we're going to talk about conditions that happens alongside. And then we will recap that because it's important that you know it for you, for your patients. So here we have the stomach. So what is the most important part about the stomach? Here is where chemical digestion takes place, the stomach. So this bolus that comes from the mouth all the way through the pharynx or throat to the esophagus to the stomach, now is going to be broken down even further in particles so small, microscopic particles, because now we're going to extract from all these solids that we ate or liquids, we're going to extract the nutrients. Remember that the nutrients are proteins, minerals, water, vitamins, sugars, and cholesterol. We have 6 nutrients. And where do we get all these nutrients? From the food that we ingest. Well, if the food that we ingest contains those minerals, those proteins, those vitamins, most of them contains carbohydrates and contains cholesterol in large quantities. Remember, that's what we develop high levels of cholesterol or high levels of glucose. And that's why all these problems arises after. So it says right here, the stomach receives food from the esophagus, mix it with the gastric juices. We're going to talk about those gastric juices in a little bit, and move the food into the small intestine. Because the stomach do not retain anything. This is just a process. This is like a station. This is like a train station or bus station or the factory. When we are going to process all this food and make it very, very small that can be absorbed and then goes to the small intestine. Then we're going to talk about what is the function of the small intestine and the large intestine. And that's it. The end of the chapter. Because we're walking through all these structures and we talk about what happened there. That means the functions. That's what is called anatomy and physiology, remember. I will not stress enough. But, to tell you all the time, anatomy means structures, physiology means the functions of those structures. And what happens with those structures do not function appropriately. We develop conditions, medical conditions. Because all of these structures needs to work in a way that every single structure connected to it is not interrupted, the functions. Now, the stomach has also layers. Remember, the entire tract, all these tubes have 4 layers. The stomach has 3 layers. So the inner layer, let's talk about the layers. Yeah. The smooth muscle. An inner layer is made of circular muscles. An outer layer is made of longitudinal muscles. Some of them are oblique. So we're going to see in an image what is it that I'm talking about. Even though if they have the serosa, the serosa, the mucosa, the submucosa, the muscularis, and the serosa, they're going to have different type of muscles that makes up the stomach. Because remember how the stomach is going to produce this side to side movement, up and down movement, see, circular, longitudinal, but then at the same time, something that reinforces these circular and longitudinal muscles so they don't break. We have the oblique, something that goes across. You will not be asked about these muscles. Mostly is the function of the stomach. Here is where chemical digestion takes place. Now, this is what I'm talking about. If you look right here, we have these circular muscles. See, these ones are circular. And this is one layer. We just showing pieces, but they go like this, they go like this, all across. Then they have these longitudinal, see? Long, and they go all the way like this, is the entire thing. And they have these oblique. So again, let's show that. Let's remove this. If you see internally, we see this oblique. See? These are oblique. These are circular. This is longitudinal. From top to bottom, to around, and side by side. Now, right here inside, remember that the stomach is an elastic muscle. It can be very small, but when it's full, it can become really large. So that's basically what it is. All depends on how we accustom our stomach with the food that we ingest. So it stretches. What makes the stomach to stretch so much? Because it has this rugged or these kind of folds. It's like an accordion. See, you put it this way, you close it, but then you can expand it and it becomes really large. That's basically what it is. That's what gives the chance of the stomach to expand and to contract, because it does all this movement. Remember, circular motion, up and down, because it's going to mix all the content, all the food that we eat is going to enter here. See, all the food is going to enter here, and then it's going to start shaking, moving it side to side, up and down, until it breaks all these with the assistance of all these particular chemicals that are secreted by the layers of the stomach. We will discuss those acids, those chemicals. Now they are so strong that they break down that food to remove all the nutrients from them. Then everything passes down in these structures. You see the sphincter right here? See, that is like a little ring right here, connects with the esophagus. There is another sphincter right here. at the end of the stomach as well, connecting with the small intestine. We have plenty of sphincters right here. Because when the stomach is moving and doing the chemical digestion, this place has to be completely closed. So food don't go backwards, remember? Acid reflux or heartburn happens here. Or if it passes right here, we're going to develop diarrhea. So that's basically what's going on right here. Let's talk about the parts of the stomach, because remember, the stomach has layers. These three types of muscles are different from the layers. Remember, the layers of the entire alimentary tract, there are four: mucosa, inner, submucosa, muscularis, and serosa. So serosa is the outer layer. The muscularis is the middle. The submucosa connects the mucosa to the middle. Let's talk about the four parts of the stomach. So the stomach has four parts. This part on top is called the fundus. Do you remember the uterus, the upper part of the uterus, the part that connects with the fallopian tube, so the salpingo? It was called the fundus. Then we have the body, all this part right here. This is the body. And then this lower part right here is the pylorus. This is the pylorus right here. And here we are going to encounter the pyloric sphincter. So this is an sphincter right here. Remember, this is the ESL sphincter, lower esophageal sphincter. And here is the pyloric sphincter. So remember, all this needs to be closed when the stomach is doing the process of digestion for a period of at least 2 hours. So these are the three parts of the stomach: the fundus, the body, and the pylori area. So that's basically what it is. Any questions about the stomach, the layers, the types of muscle? You won't be asked about that. Remember, things you need to remember is about the lower esophageal sphincter. You have to remember about peristalsis, the movement, the propelling movement, the movement that pushes the food down the alimentary tract. That's important. Here it is, see? 4 parts of the stomach. The cardia. Well, I wouldn't consider the cardia as the part, so do not even worry about that. It's the fundus, the body, and the pylorus. That's it. They call it the cardia right here, with the content goes backwards to the esophagus. You have this cardiac sensation that you have in a heart attack. Remember, many people mix up this heartburn, this acid reflux, with chest pain. Oh, I have chest pain. It hurts right here, because it is right here in this area where the stomach connects with the esophagus. And it makes you feel like you having chest pains. But I wouldn't be worried about this. Most importantly are the points that I mentioned before. Remember, the esophagus What is the esophagus? That's the structure that connects the throat with the stomach. The part that separates the stomach with the esophagus. What is the name of that sphincter? ELS, remember? Lower esophageal sphincter. That's basically what I want you to know. Anything else is just for general knowledge. Any questions about the stomach? Okay, so we are going to have here, well, it is 7. Let's take a break because this is going to take a little while to explain you all these chemicals that are going to act up on the food and it's going to help it to break down. So we're going to spend a little time. I don't want just to start a little bit and then come back again. It has to start all over again. So these are the gastric secretions. So we're going to talk about all gastric secretions or gastric juices, okay? So we're going to talk about them when we come back from break. So go ahead, have your break. We come back at 7:30 and then we continue and probably wrap up with this chapter, okay? Enjoy your break.
Thank you.
See you in a bit. Okay. Okay. So I hope you guys enjoy your break. We are going to continue with the gastric juices or the gastric secretions. Do I have all you back?
I'm back.
Yes, good. Okay. So once again, I hope you guys enjoy your break. This time it's a little cold, so just drinking something hot. That's what we need now. Okay, so let's talk about these gastric secretions. Remember, chemical digestion occurs within the stomach and a little bit within the small intestine, so we will talk about that. So let's talk about these secretions produced within the stomach. So we have the most common one, which is the one that I want you to remember, is hydrochloric acid. This is very, very important. Whenever you hear about which one is the most abundant chemical or acid produced within the stomach, is hydrochloric acid. Now, let's go back to gastric lipase. Now, pay attention to the names because the names tells you everything. Lipase, what lip or lip means. Think about liposuction. Liposuction is the removal of fat. So think about gastric lipase. ACE means breakdown. So the breakdown of fat. Remember that we have amylase before. Remember the saliva, amylase. So amyl means glucose or carbohydrates. ACE means breakdown. So breakdown of carbohydrates. This is lipase, so breakdown of fats. So every single time that we have a meal that contains fats, this is what is going to break that fat and it can be absorbed within the bloodstream. Remember, fat do not just pass through the walls because the walls are made of fat and water. And remember, fat do not get along with water. So in order to pass these fats through the membrane or through the walls or layers of these structures, it has to be broken down first. Decompose, and then it's going to be composed again when it enters the system. So lipase, so hydrochloric acid is the most common acid that we have. It's the most common and most abundant acid produced by the stomach. It is a gastric lipase. Gastric means stomach, pertaining to the stomach. So again, breaks down fat. Now let's talk about pepsinogen. Now, this pepsinogen is nothing else than an enzyme, pepsinogen. But this enzyme is in its inactive stage of form. So pepsino sounds like pepsin, right? Production of pepsin. That's basically what it is. So our stomach releases pepsinogen, but the pepsinogen by itself doesn't do anything because it is in an inactive form. If it is inactive, it's not going to do anything. It's not going to break down food. So what is it that happens to produce pepsin, because I need to decompose this. I need to break down pepsinogen into pepsin. So in order to do that, I have to use hydrochloric acid. So hydrochloric acid breaks down pepsinogen to convert it into pepsin. So hydrochloric acid is the most important acid within the stomach, because without it, you wouldn't have pepsin. Remember pep, which means digestion. Remember that I told you that's where Pepto-Bismol comes from. So that's basically what it is. So lipase, fats, break down fats. Pepsinogen has to be converted into pepsin. What chemical, what acid makes this possible? Hydrochloric acid. So if I don't have, or you don't have hydrochloric acid, then pepsin is not going to be produced. Therefore, you're going to have lots of problems with digestion. So we're not going to have all these strong acids that are going to break down food. And it is smallest particles, so it cannot be absorbed. So this person will have problems with malnutrition, because all the food that we eat, it will go as fecal material. All the nutrients will pass with the food just the way that we ate it. Just you put the word, you put the digestive system to work for no reason, because you're not going to be absorbing anything, because large pieces are not going to be passed through the membrane. Has to be very, very small pieces. So these are the gastric secretions. Once again, gastric lipase or just lipase, pepsin, and hydrochloric acid. Very, very important for us to have this. So when all these solids enters the stomach, all these processes are going to start taking place. So hydrochloric acid is going to be poured inside the stomach. Pepsin is going to start poured into, lipase is going to be poured into. So it's going to break all these big particles into very tiny microscopic particles. So then they can pass through the membrane or the walls of the small intestine, which is where we are going to talk about next, the structure that is going to allow all these nutrients to pass through. Remember, large particles cannot pass. That's what they come out as a form of physics or fecal material. So that's how it works. So if you ever have a question, just think about the big picture, gastric juices or gastric acids in general. They don't use gastric secretion. They just said, oh, the gastric juices. So which of the following is considered a gastric juice? Then you look for hydrochloric acid, because usually is the one that is there. Of course, all these acids are produced in certain regions of the stomach. Remember, certain parts of the stomach. Nobody's going to ask you that. That will be very, very detailed information. So for you, it's important just to know the hydrochloric acid is produced within the stomach. You don't need to know exactly that is produced by the parietal cells or anything else, but this is the most abundant acid within the stomach, and it helps with chemical digestion, remember. When food enters the stomach, immediately the brain sends information, sends these signals to the stomach, and the stomach starts secreting all these chemicals. So now let's talk about this. Let's assume that you are very hungry. So when you are hungry, your brain sends these signals to this part of the this section of the brain that controls hunger, the hypothalamus, and then it's gonna say, "Hey, stomach, start secreting all this acid because this person is gonna eat." So when we are hungry, we eat. What about not eating but feeling hungry? Well, guess what? The stomach, the brain doesn't know. I'm just telling you, you're hungry and you're feeling hungry. Now you're not eating for any reason. We're not going to discuss that, whether you have money, whether you can buy it, whether you are on a diet. I don't know. You're not just eating. And we're not talking about that. We're talking about what are the consequences of not eating when you feel hungry. But remember, when you are hungry, the brain saying the signals that you're hungry. You start salivating, you start wishing to eat something. But what happens when you don't eat? Well, the nervous system is going to send the signals to the stomach. The stomach is going to start secreting hydrochloric acid. This hydrochloric acid is going to be acting up on pepsinogen. It produces pepsin. Gastric lipase is going to be produced. Now, all these acids are right there inside your stomach, but you didn't put anything to break down. What is it that these acids gonna do? They're gonna break down the mucous membrane of your stomach. Think about all these acids, but there is nothing else there to break down. Now you develop gastric ulcers. Now you develop gastritis. That's how gastritis happens. Not that you just not eating or you're not eating enough and you have too much of the gastric acid versus the food that needs to break down. Or you're not eating and you have all these excess of acids. And on top of that, you have this excess of acids and you add spices. You add something that is too salty. So now you smoke, you drink, you burn your stomach even further. So you're gonna damage the lining of your stomach inside. Now you're gonna develop gastritis, which is another very common condition of the digestive system. But the first one is heartburn, remember, esophageal reflux or just acid reflux. Then gastritis. And this because the stomach is being bombarded with all these acids, but you didn't put enough food there to be broken down. Or you have enough food, but you add spices, you smoke or alcohol, you add it to it. And that contains these very strong acids that is going to help to, damage your the lining of your stomach even further. So that's how things happen. That's why we have to eat certain things that doesn't cause us, damage to our stomach. That's why the doctor tell you, oh, eat, choose some, what is called some, I forgot. Well, some milk or magnesia, some Pepto-Bismol because they are antacids. They neutralizes the excess of acids, and that's what it releases. It relieves a little bit the sensation of the burning sensation when you eat. Tums, those are the tablets that I was talking about. Yeah. So there are certain things that you have to drink, but this is just temporarily. But if the damage is done, that is just gonna cool down. That's like I'm hot and I just take a shower, but a little bit after, I'm gonna continue being hot for sweating or something like that. So this will be the gastric secretion. It's very important to understand gastric secretions for your own good, so you can understand when the patient comes in. Once again, remember, it's not our job to tell the patients, oh, so you're eating this and the professor told me this, or you just have this. Remember, we're not supposed to be diagnosing. We just know what the patient has and we have an idea what the doctor is going to order, what exams probably the doctor is going to do, or what is the diagnosis the doctor is going to do. So we are prepared to give kind of guidance to the patient, explanations to procedures, things like that. So you can explain them, you can reassure the patient and give, guidelines about what to eat, what not to eat, what to stop. So the doctor is going to ask you, stop smoking, start drinking. You are eating all these spices, all stuff. You got to stop because that's going to damage the lining of your stomach. Any questions about these gastric secretions? Remember, hydrochloric acid is the most common. Usually we call them gastric juices because these are secretions that are produced by the stomach. Later on, we're going to see other secretions not produced by the stomach, but they are going to have some functions with this food before it is absorbed and sent to blood, the blood flow. See? Clinical applications, a common problem, heartburn. I told you already. It's the most common condition of the digestive system. Remember, this is called gastric reflux. Esophageal reflux is how we call it. So how that happened? Remember, this is called stomach ache. So sometimes you feel like this burning sensation in your stomach or on your chest, and you mix them up for heart attack. So it's a lot of stuff. See, it takes 20 minutes for the hypothalamus. I already mentioned it. This is one of the glands within the brain that controls the sense of, being hungry. So when this is part of the nervous system realizes that, okay, your stomach is receiving food, you are hungry, then immediately send all these signals so the stomach start producing all these gastric juices. Now, you eat too much. Oh, that's another thing. If you eat too much, sometimes we feel like our stomach is full, but we still put in more, regardless of the reason. Oh, I was in a restaurant. I didn't want to leave anything. Oh, it was not enough like to ask, take it home or anything like that. Oh, I just want to eat it all because when it gets home, it's going to be cold. I'm not going to be home for a while sometimes. I'm going to go somewhere else. Or you just happen to eat too much. So then you get the stomach so full that this sphincter right here, the lower esophageal sphincter, does not close. Or you keep on putting food, and the stomach is still working already because it's full, and you put in more food. So the brain cannot control anything like that. It just sends the signals. But it doesn't know that you just stop eating. Your stomach is full. So now you put in more food and more food. So then the sphincter is going to be open. It's going to relax and food start pouring in, but your stomach is already churning. It's already working in the gut. And because the upper part of the stomach, which is when it connects to the esophagus, where the lower esophageal sphincter is located, is open, then food content with all these acids move to the esophagus, and it burns the part of that area of the mucous membrane of the esophagus because it's too acid. Remember, we can call it different names. But heartburn is a very common layman term that we use, besides it's in English. But the esophageal reflux, that is the most important term, or gastric reflux, or acid reflux by itself. Remember that I told you that the way that we treat it is using antacids because you have too much acids in there. So antacids will give it like Tums, like milk magnesia, like Pepto-Bismol. There is another one that I just slipped my mind. But that's basically what it is. But this is temporary relief. You can take it right after you start feeling the burning sensation. But still, it's not going to fix the problem. So what will fix the problem? Prevention. Eat small meals, meaning eat small portions. Don't eat too much. Eat slowly. If you eat in a hurry too fast, you're not chewing. You're not breaking down this food the way that it's supposed to. These pieces they're gonna enter to the stomach, too large pieces. The stomach is not gonna be able to break them down. So you're gonna pass them as a feces. Stay upright. Remember, do not lay down after eating, at least 2 hours after. But if you eat and you're in your couch eating, you're gonna develop acid reflux. There is no question about it. 100% guaranteed. If you lay down, if you start doing exercise when you just ate, well, you're moving, you're shaking, you're active, it's gonna send the contact upward. See, avoid caffeine. I mentioned all these. Caffeine, nicotine, that's cigarettes, and alcohol. All those things increases. You're gonna say, oh, how caffeine is gonna do it? How caffeine and nicotine, what they do is they accelerate the muscles. Remember, we take caffeine or nicotine because, oh, we are so stressed. Oh, because we are falling asleep. So this makes the stomach very active. So it starts shaking and shaking more, faster. So it's going to be faster. So all the content that it is within the stomach is going to go up. And it's going to relax the sphincters. So the sphincters are going to be kept open. So the content of the stomach is going to go either way, lower or upper, or you develop this acid reflux, or you might develop diarrhea. Alcohol contains lots of acid, so increases the acidity inside your stomach. So an excess of acids inside your stomach can cause damage, not only to the content that is regurgitating, going backwards to the esophagus, but to the lining of the stomach as well, causing gastritis. So it's a lot of things going on. Any questions about this? Remember I explained it to you before. Now It is here. It is written, so you can go over and read it. But I explain it in mostly my own words, so you can have a better understanding how all this process happens. Let's talk about the pancreas. So remember the pancreas now, it is one of those accessory organs. The pancreas is not part of the digestive system. That's what's called an accessory organ. Just like the teeth. Can someone without teeth eat? Yes. I see many people without teeth and they eat. Well, I haven't seen anyone without tongue or without the salivary glands. So that it's a little difficult to argue. Or to give you an example, I haven't seen it. Probably in the movies, somebody cut somebody else's tongue, or you heard in the news. But this is not something common. But even though if you don't have a tongue, you're not going to be able to talk. But you are going to be able to eat. Remember, I can put something through your mouth, a tube, a feeding tube, still goes directly into the stomach. Remember, we talk about the ovaries that are the essential organs, the testicles being the essential organs, the male and female reproductive system. They are essentials because without them, there is no life. Because the sex cells are produced there, the sex cells. But if the sex cells are not produced, what life are you going to have, even though if everything else is there? Here the same. We need to have the stomach because it's a very important organ. We need to have this tube that connects the mouth with the pharynx, with the stomach. How else we're going to bring the food right there? But the teeth and the tongue and the salivary glands, they are not primary parts. Because without teeth, you still can get your food. Without tongue, assuming that something like that happens, still you can get your food, can go down by gravity. You just put it in your mouth, it goes down, or you put it with something else, still can go down, or you can use feeding tubes, still can go down. See the difference? Now, the pancreas is an accessory organ because it does not belong to the digestive system. It's not part of the digestive system. So it says right there, the pancreas is an endocrine gland. So what is an endocrine gland? It produces secretions inside the organ and it is released within the system, but it doesn't leave the body. So whatever is produced by this gland, it doesn't go outside the body, stays within the body. That's what it's called endo, within. Endocrine. Crine means secretions, internal secretions. Now, the pancreas is so important because it produces insulin. This, you need to know it. These are questions for exam. Which gland within our body produces insulin or secretes insulin? Usually they produce insulin. They don't ask for glucagon, but I'm going to explain it, what is the function of these two. Insulin, it regulates glucose. So remember that I told you that whenever we eat something that is very fatty, very greasy, lipates. breaks down that. So what happens when we eat something that it has too much sugar? Insulin. Insulin. But insulin is within other areas of is within the blood, but the pancreas is going to secrete these secretions are going to go to the bloodstream. So that's basically what it is. It's part of digestion because it's breaking down glucose, which is one of the nutrients. It's going to regulate the amount of glucose in our system. So when we eat something that is very sweet, immediately insulin is going to be secreted because insulin is going to bind. This is like oxygen and hemoglobin. They bind together. This is like a magnet. So insulin is going to be secreted from the pancreas and it's going to go to the blood flow, to the circulation. And right there, it's going to bind with glucose. So it's going to enter the amount of glucose that each cell needs. Because remember, glucose is used as energy. And we need energy. But if you consume too much glucose, guess what? We produce more insulin. But if you have an excess amount of glucose consuming every day, there is not enough insulin to get rid of all this glucose. So for that reason, you become diabetic. So insulin controls the amount of glucose within the blood. Now, what is glucagon? Well, glucagon, as the word implies, it means glucose. So the pancreas produces glucose. It also produces something against glucose, against excess of glucose. Okay, I'm confused, professor. So we have insulin to regulate the amount of glucose that we ingested. Remember, this is to control that glucose. Well, then why do we have glucagon? We shouldn't have glucagon because we are eating it. Well, let's put it this way. Let's say that you haven't eaten for a day. If you don't eat and your glucose levels becomes very low, which are very dangerous too, what is it that our body does? The pancreas produces glucose to make up for that glucose that we did not ingest in our diet. See how perfect our body is? That if we don't have glucose, our body produces it, but in very small quantities, just to keep us going. But if we don't eat for quite some time, then, well, we're going to die for any reasons, right? So the pancreas produces insulin to regulate the amount of glucose that we ingest. But when we do not eat enough carbs or glucose or whatever the case may be, then the body produces glucagon. But it's not going to be enough. It's just to buy some time. Meanwhile, we get some sugar, some foods that contains glucose or carbs. So remember, questions for the exam, which gland produces insulin? Or they reverse the question. Insulin is produced in which of the following glands? The pancreas. What is the function of insulin? Regulates blood glucose. So that's basically what it is. So the pancreas is one of those glands that is double gland. What do you mean by double gland? Not only produce the endocrine secretions, not only considered an endocrine gland, but it's also called an exocrine gland. That is called a mixed gland. This is a mixed gland. It is both an endocrine and an exocrine gland. Why? Because it produces pancreatic juices. And these juices are going to go to the stomach and the small intestine. So that's basically what it is. So it goes to another structure, not to the blood flow directly. But that's not what you need to know. Just for you to know, think about what is produced, where insulin is produced. That's A. And what is the function of insulin? Remember, which of the following secretions or substances, or which of the following regulates blood glucose? Insulin. What is insulin produce? The pancreas. Or the pancreas produces which hormone? Because remember, insulin is a hormone because it's produced by an endocrine glands. Every single endocrine glands produces hormones. So that's basically what it is. So this will be the pancreas. Any questions about the pancreas? Very, very important organ. Remember, independently of whether it's an accessory organ from the digestive system, it is important because it produces this very common hormone called insulin. Remember that in this country, we have tons of people suffering from diabetes. And that is the problem with insulin, whether we're going to talk about the types of diabetes later on. So for now, this is the one that controls the amount of glucose inside our blood system. And if we have too much glucose inside the system, then we're going to develop diabetes, remember. Here are the pancreatic juices. Now this is the exocrine part of the pancreas. Remember, insulin and glucagon is the endocrine part. The pancreatic juices are these enzymes. So look at this, not difficult to remember. We know that it is the pancreatic because we're talking about the pancreas. If we're talking about the stomach, it's the gastric acids. This is the pancreatic juices, the gastric juices. So here's the pancreatic amylase. Oh, where do we have amylase? Salivary glands, remember. It breaks down starch and glucose or carbs. Remember, carbohydrates, carbs, shortened, which is the for glucose, which is an abbreviation for carbohydrates. Instead of saying carbohydrates, because it's very long, we said just carbs. So it breaks down sugars. And lipase, we talked already about lipase because we have gastric lipase. It breaks down fats. We have the pancreatic proteins. Proteins breaks down proteins. Remember, ACE means to break down. That's why the pancreas is considered a mixed gland because it has the endocrine, insulin, glucagon, and it has the exocrine part, which is these enzymes, amylase, lipase, and protease. And it's called the pancreatic juices. Any questions about the pancreas? The endocrine or exocrine part. Remember, particularly the endocrine is the one that is being asked the most common. So insulin, insulin, insulin. But remember, diabetes is a very common medical condition, particularly in this country. So we need to know about insulin. So this is the pancreatic secretion, where the pancreas, so just to show you where the pancreas is located, see? This is the pancreas. This is the place when we have some beta cells and some alpha cells. Within, here are some islets, some little like islands. And within these islands, we're gonna have insulin being produced and glucagon being produced. So beta cells, remember beta cells. Oh, nobody can see this. So beta cells produces insulin. Alpha cells this is a P, produces glucagon. So these are located right here inside the pancreas. So the pancreas also produces these pancreatic juices, and they're gonna go not to the stomach, they're gonna go to the small intestine. So it's gonna be some channels around here, the pancreatic ducts. So it's gonna bring right here these juices, lipase, amylase, and protease, and it's gonna put it right here. So whatever from the stomach passes right here, some food is gonna be further broken down, but particularly fat, proteins, and glucose, because these are very large particles, very large molecules. So within the stomach, we do some kind of chemical digestion. But in the first section of the small intestine, that later on we're going to call it names, is going to be the other part that receives pancreatic juices. And bile, here from later on, we're going to see this part. Oh, what did I do? The pancreas right here. Later on, we're going to see this is the gallbladder. Remember, this is another accessory line, accessory organ that is connected to the liver and is going to produce bile. And it's going to come right here to this area also. And I'm going to tell you what is it that bile does to all this food before it is absorbed. So it is a lot of stuff going on right here, but I don't want you to put too much things in your head. I have to explain it to you so you know why is it that these particular secretions are produced, not just mention then, oh, insulin this, then you didn't learn anything. I have to tell you exactly what they do, what is the function. Remember, anatomy, physiology. The structures, it is function. But what is the function? If we mention the structure that produce these particular secretions, we need to know where they are acting upon. What is it that they're doing? What is the function? Do they break sugar, fat, proteins, carbs? So that's how important it is to know about all these structures. Let's talk about the liver now, another accessory organ. Now remember, the liver is right there next to the stomach, next to the pancreas. All these organs are very close to each other, or I might say close to the stomach. And they play an important role in digestion. So pay attention to what I'm going to say, because these are possible questions for the exam. Which is the largest internal organ? Liver. Remember, which is the largest organ? The skin. But it says internal. So don't get confused. The largest organ by surface is the skin. But if it says the largest internal organ, it is the liver. So don't forget about that, because these are crucial questions for exams. Remember when we were talking about the quadrants? It is located on the upper right quadrant. See? Don't worry about anything else. Right upper quadrant. Because that's what's important right here. Yes, it has this reddish, brownish color. That is okay. Now, what does the liver produce? That's another key question right here. It produces bile. This is that greenish, bitter secretion. Sometimes people has been vomiting a lot. And when they vomit a lot, after they ate at McDonald's, Kentucky Fried Chicken, White Castle, Chipotle, all this fast food that contains lots of fat, then more bile is produced, because the bile helps to not only to break down fats, but to camouflage fat. So that's something that is important that we're going to talk about when we get to the absorption part. So be careful with that. Where is bile produced? The liver. Be careful, because the gallbladder do not produce bile. The gallbladder stores bile. See, it stores and concentrates bile. But bile is produced within the liver, just like insulin is produced within the pancreas. Bile is produced within the liver. And it is stored within the gallbladder. So the gallbladder do not produce bile. It's just a storage room. After it is produced in the liver, it is sent for storage in the gallbladder. Anytime that you eat a fatty meal, immediately this gallbladder starts secreting this bile through the tubes to the common bile duct, and it goes right there to the small intestine. So remember, every single time that we eat lots of carbohydrates, then amylase is released within the mouth, within the pancreas, but then also some other organs are going to be releasing something else. So that is the function of all these internal secretions. That when we eat something, we have lots of stuff, lots of food, lots of nutrients that we need to separate, to limit the amount. If we eat too much, they try to cut it down. So not all these fats, all these glucose enters in our system. Remember, we have 6 nutrients. I've been saying this over and over. Fat, glucose, proteins, minerals, vitamins, water, 6. The most abundant of those 6 are fats and glucose. Fats and glucose are the things that we eat the most, and they are in large quantities in the foods that we eat. Fats and glucose, whatever the body do not use, it stores that. It keeps it inside our body. So if we don't eat that for quite some time, then whatever is stored is going to be used for later on. It's like leaving leftovers for tomorrow's dinner or lunch. But because we start eating and eating and eating glucose, because everything has glucose, everything has fat, because that's what we eat the most. And these are the nutrients that comes in large quantities. You have a little piece of bread has large quantities of sugar. You eat a little piece of meat, lots, or pizza, lots of fat, plus carbs. Because the bread of the pizza, the cheese, grease, fat, glucose. And it comes in large quantities. So whatever we don't use is going to be stored in our body. And we keep storing. So our body becomes like a hoarding person. Stores. Then we don't have a space where to walk through. So you gain weight immediately. You start gaining weight. That's the reason we have all these enzymes that help us to break down. But when we go over the limit, if we eat more than we are supposed to be eating, well, we're not going to have enough because the body has certain limitations in producing these enzymes to break down these nutrients. So that's basically what it is. On top of that, we don't do exercise, we smoke, we drink, even worse. So we're not burning these fats and carbs. So for that reason, we're gonna gain weight. Okay, so the liver is called the detoxifier of our body. Every single medication, well, not everyone, but let's say 98% of the medications that we take passes through the liver. Whether it is oral medication, IV medication, IM medication, SB medication, it doesn't matter. Remember, intramuscular, intravenous, subcutaneous, or oral medications, all those medications are going to pass through the liver. So when they get into the liver, they're going to be they're going to activate this medication. If they don't pass through the liver, this medication will never be activated. That's why we have certain medications that are taken orally, others are taken intravenously, others intramuscular, subcutaneous, or topical medications, because they are absorbed in different ways. So if you take the medication, if I give you the medication on the wrong route, it's supposed to be given through IV and I gave you intramuscular, it's not going to work. So all these medications are going to end within the blood flow. All the blood passes through the heart, all the blood passes through the kidneys, all the blood passes through the liver. So when it passes through the liver, all these medications or all these chemicals, whatever the chemical may be, if it is a toxic, it's going to damage the liver. If it is an excess of medication, that's when you got an overdose. It's going to damage the liver. It's going to kill you. And if you take in too much of this medication over and over and over, it's going to damage your liver. That's why the doctor gives you a certain amount of medication, certain dosage, to take it a certain time. Because if you're not taking it away and you take more than or less than, well, it's not going to work. But if you take too much, then it's going to affect the liver. Because the liver needs to break down these medications to make them active. Meaning, now the medication is going to do the purpose of the medication. But if your liver is not working and the medication has to be broken down by the liver or activated and it's not working, then the medication is not good. That's why people who have liver problems, remember, they're going to have a lot of problems with medications. So it is the detoxifier. Any chemical, anything that you have passes through the liver. And if it is too much, it's going to intoxicate your liver. It's going to attack your liver. It's going to damage your liver. That's why we cannot just go to the pharmacy and get the medications for ourselves. There are some medications that are called over the counter, but these medications are medications that are considered safe in most of the cases. The problem is that we abuse. We take too much of the medication, but they are considered safer. Other than that, we have to go to the doctor to a process of evaluations, blood tests, and things like that. They have to analyze what is it that we have, what is it that we don't have, what is it that we need. And then the doctor decides which medication is the more convenient for you, according to your own picture presentation. So that's basically what's going on right here. So remember, the liver is the largest internal organ. It produces bile. Don't worry about anything else. It produces bile. What does the gallbladder do? Stores bile, not that it produces it. So in your exam, I'm going to send you these questions. So you need to keep it in mind. Any questions about the liver? Good. So here's the liver. It's a very large organ, you see. It has two lobes, see? One here, one here. But don't worry about that. You see the gallbladder right here? This green structure, it has some tubes right here. So the liver produces the bile, store it right here within the gallbladder. And when it's needed, is going to come out through these little tubes. Let me change name right here. So it's going to go through these 60 tubes and all those tubes right here. And it's going to go to the small intestine. Remember, this is activated when you eat something that has lots of cholesterol, lots of fat. Any food that contains fat makes this gallbladder to release bile. Then the liver starts producing bile and filling in this because storage is produced here, then send it here for storage. So when you eat a fatty meal, immediately the gallbladder secreted and it goes to the small intestine. So that's basically what it is. So remember, the gallbladder stores bile. Where is bile produced? This is an enzyme. It is produced within the liver. So the liver produces bile and it is stored within the gallbladder. That's it. Now we're going to see the gallbladder, right? Clinical applications, hepatitis. Now, for those who took medical terminology, we know already. Iris, inflammation, hepat, liver, inflammation of the liver. See? Inflammation of the liver. Of course, there are many conditions that happens to the liver. It can be chronic, can be acute. All depends. Something that can be temporary, something that can be permanent damage. So usually what causes the most common cause of hepatitis is a virus. So hepatitis B virus, hepatitis C virus. These are the most common, particularly hepatitis B virus. What else can cause that? Alcohol, alcoholics. If you're an alcoholic, you're gonna damage your liver. Drug users, see all these chemicals go there and intoxicates, destroys the liver. So that's basically the most common causes. We're not gonna go into more details here because I don't want you to kind of feed you with all this information and then you're not gonna remember much. But for hepatitis, just this. Inflammation of the liver. The most common cause of hepatitis is hepatitis B virus. Of course, the C too, but the B virus is mostly common. And alcohol. So if you don't see hepatitis, not hepatitis A. Remember, hepatitis A usually is a very mild type of hepatitis. B and C, they become chronic if it's not treated. So if you see in your exam, you don't see hepatitis B or hepatitis C, then think about alcohol abuse. Okay, so that's basically what it is, because we mentioned things that damage the body. So alcohol is really bad for a lot of stuff. Because it's a detoxifier, it's going to damage the excess of alcohol, is going to damage the liver. Any questions about hepatitis? Think about inflammation of the liver. The most common cause, remember, hepatitis B virus. and alcohol. Let's talk about now the gallbladder. Remember, the gallbladder stores bile. Now, bile is the one that kind of mimics, kind of camouflage fat. Think about that. So bile has lots of cholesterol. Remember, it's the one that acts against cholesterol. So if you have an excess of bile, concentration, meaning too much cholesterol, then you're gonna form little stones in the gallbladder, as you can see here in this image. This is a CAT scan of the liver, the gallbladder. So cholesterol, remember, bile acts up on cholesterol. Therefore, biles make cholesterol. And when you have too much bile, concentrated bile, all this cholesterol is gonna make like a little stones. That's what is called gallstones, gallbladder stones. But they are made of cholesterol. Whereas kidney stones are made of calcium. And these are made of cholesterol. So someone who suffers a gallstone problem, this is an emergency situation. Sometimes they have to remove your gallbladder. Gallstones are very common in females between the ages of 40 and above. It can be a little younger, like 35, but most of the case is 40s. It happens more to females than to males. Okay. So the only thing that I want you to remember here is that gallbladder, remember, stores bile. Bile has to do with cholesterol. So remember, bile is secreted when a person eats a fatty meal, because it has to go over there and try to break it down, make something, hide it, camouflage it. Okay, so now we continue with the structures of the main structures of the digestive system, small intestine. So we went through the mouth, through the throat or pharynx, to the esophagus, stomach, now small intestine. So very important, because now we're gonna see what happened during the small intestine. This is a tube, just put it that way. This is one of the tubes that carries the food from the stomach through to the large intestine. Let's talk about the parts, and then we go back to explain more about this. So the small intestine is divided in 3 parts or segments. Because I want to go first through this, then I can tell you the major function, which is absorption. So let's talk about the structures first. So the first segment, or the proximal segment, the one that is connected to the stomach, is called the duodenum. Remember, the ones who took medical terminology with me, I explained this. This is the first section. Then the middle section, or portion, or segment, is the jejunum. And the distal portion, the portion that is connected to the large intestine, is called the ileum. Now, Within these structures, particularly within the duodenum, which is the first segment of the large intestine, most of the absorption is going to happen here. So all the food that was processed, that was chemically broken down within the stomach, is going to move to the small intestine. Right there in the first segment, all the nutrients are going to be passing through the blood flow through the walls of the small intestine. That's what is called absorption. That's basically what it is. So all the small intestine, they are, the function is to absorb the nutrients and pass it to the blood flow. And whatever is not good or it was not absorbed is going to go to the large intestine as a fecal material. So that is basically what it is. So remember that I told you that the food that we chew within the mouth or masticate is going to form a bolus, right? So it is a bolus, like a ball, remember, like a meatball. Bolus is the food that goes from the mouth. It's a bowl of food alongside with saliva. It makes this moist and make a ball and goes all the way down from the mouth to the pharynx, to the esophagus, to the stomach. It ends right here. Now this is going to be broken down in little pieces, very small pieces, with all these gastric juices. Then it's going to pass to the small intestine that has 3 segments. So most of the things are going to be absorbed right here. But here is when the pancreatic juices are coming. Here is where the bile comes. And here, the food that passes here, remember it was bolus, now it's going to call chyme. Sometimes people produce a chyme. I learned a chyme my whole life, but I heard people saying it chyme, but it's the chyme. Chyme is this food that was already processed within the stomach that passes to the small intestine. So when it reached the stomach, it just changed the name. So bolus from the mouth, the pharynx, the small intestine. As soon as it enters the stomach, and because all these gastric juices are acting on to break it down in a small part, it becomes chyme. Now this chyme moves to the small intestine, and here is where, once again, the pancreas sends the pancreatic juices, bile sends the bile juices to break down even further down these structures. Remember, carbs, because are large molecules, fats are large molecules, proteins, large molecules, so they are broken down even more. So they can pass through these little pores that the membrane has, and it goes to the bloodstream. Whatever is not absorbed, whatever is not needed to be absorbed, is going to pass to the large intestine as feces, as a waste. So that is what we are discussing right here. So it's very important for us to understand from where to where the food is going through and what happens in every single station, if you will, every single time the food passes. See, if the food ends up in the mouth, what happened there? The food passes through these channels, enters the stomach. What happened there? Then enters to the small intestine. What happened there? Remember, it's absorption within this small intestine. What happened after that? Well, whatever passes through the large intestine is going to be waste. We're going to get it out. It's called excretion. So that's how the whole process goes with this system. Any questions about the small intestine? Remember, the small intestine receives food that is known as a chyme from the stomach. There is gonna be received some pancreatic juices and some bile. Well, here it is. I mentioned it, but I was not pointing at pancreatic juices and bile. And absorption takes place here within the small intestine. The rest is going to be transported to the large intestine. See, everything is right here. It's just summarized. It's just that I explain it to you a little more details so you can kind of, understand better the process through all these digestive tract. Any questions about the digestive system? I mean, the small intestine. Here it is, the small intestine. So once again, let's point this out. So this is the stomach. This is the lower part of the stomach that is called the pylorus. Now here it connects the small intestine. All these pinkish convoluted tubes right here, I'm not gonna go follow everything up to here. They're called the small intestine. But the first part is called the duodenum. Then this part right here is called the jejunum, and everything else is gonna call the ileum. So it is just 3 segments in which the small intestine is divided. So food from here moves through this pyloric sphincter, moves to the small intestine. Here we have the pancreas producing all these pancreatic juices are secreted right here. Bile is secreted right here. Now this food right here is broken down even further, meaning smaller pieces, microscopic pieces. Now they can be absorbed through these walls of this small intestine. And then go to the blood flow. So here is the first segment of the large intestine, which is the ascending column. But this pouch right here is called the cecum. So very important now that we move to the large intestine, so you understand what parts are important, what question may arise from these structures. So most of the absorption happens within the small intestine. So remember, whatever is not being absorbed passes through the large intestine. That's it. That becomes waste. The large intestine. Now we're getting to the last part of the intestine. Then we go to the rectum, the anal canal, and that is it. Now it's called the large intestine because it's very white. That's it. It's larger than the small intestine. That's what's called small intestine because it's a very, very tiny. So basically that is it. So stores and secrete wastes. So that's mostly the function of the large intestine. Everything that enters the large intestine is going to be excreted, not secreted, excreted. Secretion means internal. Excretion means outside, exit. But it doesn't end right there. We're going to talk about the parts of the large intestine. Because the same way that the small intestine is divided in parts, the large intestine as well. So we're going to talk about that. Here it is. The large intestine consists of the cecum, the colon, the rectum, and the anal canal. Now pay attention to this because sometimes we get a little mixed up with these explanations, details, descriptions, if you will, of these structures. The second is a pouch. It is the first part of the large intestine. One of the important things about the cecum is that the appendix is attached to the cecum. And the appendix is a very common question asked in exams. Why? Because we have a condition that is called appendicitis that is very, very common. So for that reason, the cecum is important. Not because it's the first part or the beginning of the large intestine, but because the appendix is attached to it. Then we're going to have the ascending, the colon. The colon is divided in three parts. The ascending colon, the transverse colon, the descending colon. Now it says right here, the sigmoid portion. Remember when we were talking about the digestive system in medical terminology, I told you about the sigmoid structure. It's part of the descending colon. But it's the distal portion of the colon. Remember, this was Dr. Sigmoid that discovered that colon cancer was most commonly found on the distal part of the colon. So here, see, this is the sigmoid colon. So this part right here is called the sigmoid colon. This is the rectum. And this is the anal canal. So the whole thing right here is the descending colon up to here. But it's divided. Descending colon and the sigmoid, because the sigmoid is more likely right here. So they do a procedure that is called sigmoidoscopy because they're going to look for masses, tumors, cancer right here in this area. Now, not anymore, that changed. Because now we have colonoscopy, which is putting a scope all the way through the cecum. So we're going to observe the entire part. But don't get too caught up on this structure. Just say ascending colon. See, this is the ascending colon, starting right here with the cecum. See the appendix right here. Here is the small intestine attached to it. So ascending colon, transverse colon, descending colon, rectum, and the anal canal. That's it. That's all you need to know. Just colon by itself means the entire large intestine. Remember, the cecum is important because it contains the appendix, which is right here. So if they ask you where is the appendix located, you're going to look for the large intestine. If the large intestine is not there, look for the cecum. If the cecum is not there, the ascending colon. But usually they give you the cecum or the large intestine or the colon. So that's basically what you need to know. Not much from this chapter, but I already told you. So now all see, it carries physics. So everything that enters right here from the small intestine that was not absorbed is gonna enter here and it's gonna accumulate and usually goes to the last part. See? Now it piles up right here because when you eat, usually all the food goes to the lower part. So if you cannot move your bowels, it accumulates, you develop constipation. That's basically what it is. And because you develop constipation and because the feces are here, and what are the feces are? Waste. And waste, if they stay too long right here, they're gonna spoil. And if they're gonna spoil, they're gonna liberate microorganisms like bacteria. The bacteria damage the lining of the colon. And if you damage the lining of the colon, now you are prone to develop cancer or other type of infection, other type of conditions. Remember, stools should not be stored right here. It's going to store it for a little while because you don't need and go to the bathroom immediately. Usually, you should go to the bathroom to move your bowels once, twice, 3 times per day. That's normal. But it's not normal not to go to the bathroom within 3 days. Oh, 2 days passed. Didn't go, move my bowel 3 days. If you pass 3 days not moving your bowels, you develop something that is called constipation. That's it. So you got a problem now. Now you have to push. Now you have to strain to get the stools out. So the reasons are not drinking enough fluids, not eating enough foods that contains vegetables or anything like that. So fiber, need fiber, fruits. So that's how it works. Any questions about the large intestine? Okay, so we have here some structures that I'm going to explain tomorrow because this has to do with sphincters, with hemorrhoids and all that stuff. We're going to leave it here because I think there is time already. I'm going to leave a little for tomorrow. It's a lot that we have covered. So we're just going to stick right here with the large intestine. Remember, the large intestine is the one that carries the wastes out. So remember at this part, the last part of the descending column, we're going to find the rectum and then the anal canal. And that little part that we will see in here, this is the rectum and the anal